Hi guys, today I'm going to work through the worked examples from jacplus exercise 4.5. So this is log graphs. So I thought first I'll just show you the basic log graph, and to do so I'll start with an exponential. So exponential graph, which we've done quite a bit, looks somewhat like this. And that could be y equals e to the x. And the features of this graph is that it has a horizontal asymptote. And so that's going to be y equals 0. The second thing is that it is going to have a y-intercept here, and that y-intercept is going to be at 1. So think about it, if x is 0, we sub a 0 into x, anything to the power of 0 is 1. So it doesn't matter if it's e to the x, 2 to the x, 10 to the x, doesn't matter. It's going to be a y-intercept of 1 there. So y-intercept, 0, 1. The third thing we want to talk about is the domain, which is R, and the range, which is R plus, which of course means from 0 to infinity, not including 0, so that's because of the asymptote. So that's our exponential graph. Now a log graph is the inverse of that. So if I draw my y equals x line like this, then my log graph is going to be like this. They are going to intersect on the line y equals x, and then everything is the opposite. So first of all, for this y equals log ex, it could be log 2x, log 5x, whatever, it's a log graph. The first thing is we have a vertical asymptote, of course, at x equals 0. And then we're going to have an x-intercept at 1. So we had a y-intercept of 1 for the exponential graph. For the log graph, we have an x-intercept of 1. So because they're inverses, obviously x is swapped to y's. So our domain here is going to be the range of the exponential, which is r plus, or 0 to infinity, not including 0. And look, you don't need to see the exponential to know that. We can see that it asymptotes on the y-axis, and this gives information as to why we can't log a negative. So if you have log of negative x, and let's say negative 2, well, that doesn't work, and that's why we don't have any graph in the place in the negative zone there. So our range is going to be r, and that is the domain of the exponential, of course, because they're inverses. So be careful, there is no horizontal asymptote. Sometimes people will think there's an asymptote up here for the log graph, or here for the exponential. No, there's not. So there's just one asymptote on each of them. So look, let's now look briefly at the reflections, because they'll come up in our table of transformations. So if we have y equals log ex, and let's say we've got y equals log e neg x, and we've got y equals negative log e x. So y equals log ex, well, we've already discussed that. That looks like this. And the x values that can go into that, so the domain of this is going to be r plus. So only positive x values there. Well, if we have the log of negative x, we can't log a negative. So that means the only values that can go in here are negative for x, because then we get a double negative. So that means that it flips over the y-axis like that. Our negative log ex, well, that flips the other way, because we still can have just just positive values going into x there. So still only positive values, but we flip this way. So these are our two different reflections. And if you remember back to the formula for noting transformations, you would remember that this one here it comes before this one here. So this one is a reflection about the x-axis. X comes before y. And this one in here, this is after this. So if we go left to right, this one comes after this one here. So this is going to be a reflection about the y-axis. And x comes before y, so we see the x reflection first. So now that we've dealt with those reflections, let's go and do the examples. So we're going to be sketching each of these log graphs. So this one, log e x minus 2. So I'm just going to highlight the transformation here. The parent graph, just normal log e x. There is no dilation or reflection. We do have a horizontal shift. And remember, the same as for quadratics or hyperbolas or truncus or any of the graphs, this is connected to x. And in this case, it's in brackets with the x. And of course, we go in the opposite direction. So this horizontal shift has quite a obvious effect on the graph. We're going to go 2 in the positive direction. So I move my asymptote to x equals 2, and then I just draw the graph in like this. So we can see we don't have a y-intercept, we do have an x-intercept. So x-intercept, I'm just going to do it over here, there is no vertical shift. So this is y equals log e x minus 2. So the vertical, there is no vertical, so we can, I'm going to put the x-intercept working out here. So x-intercept when y equals 0. So let's see, we get 0 equals log e x minus 2. So e, and I might actually write it like this, because an e to the power of 0 equals this, just the way that logs work. So x minus 2 equals e to the 0, and e to the power of 0 equals 1. So x minus 2 equals 1. Anything to the power of 0 equals 1. Add 2 on both sides, x equals 3. And look, this is only one point that we've been given on this graph, or that we get, because there is no y-intercept. Now, this point does show that we've had this transformation here. So really, you probably don't need a second point there, but for the sake of just, if you're unsure, you should always put a second point. So I'm going to put a second point there, and I'm going to say it is 4. So I'm going to say when x is 4, y equals log e 4 minus 2. So y equals log e2. And it doesn't matter what other point you put on there. So if you're looking at the answers and they have a different point from you, that's okay. As long as you've got one more where necessary. So in this case, not strictly necessary, because my -2 here, my horizontal shift, is shown by the point 3, 0. All right, let's move to the next one. So this one's going to have a horizontal shift, but it's also having a vertical shift. So let's see, parent graph, y equals log ex, no reflection or dilation, and my horizontal shift is 1 unit in the negative direction of the x-axis. So that's a bit yuck. So something like this. So that's going to be y equals log e x plus 1. And don't forget your asymptote. And then, well, now we've got to go up 2 units. So remember, a vertical shift is not connected to the x, and also it's the same direction. So now I'm going to go up by 2 units, and this vertical shift, well, this is where we definitely will need another point. So x equals -1, that shows that I've got a horizontal shift here, but when I go up 2 units, this is a sketch graph, so we can't see that this has changed in any way. So if I just put the x-intercept there, well, that's not going to be enough. The y-intercept, that will give us our second point, and that will take into account the +2 on the end. So y equals log e x plus 1 plus 2. So let's do the y-intercept, where x equals 0, so y equals log e, 0 plus 1 is 1, plus 2. E to the power of 0 equals 1, anything to the power of 0 is 1, so that's 0 plus 2, y equals 2. And my second point, the x-intercept, so y equals 0 log e x plus 1 plus 2 equals 0. So now we get log e x plus 1 equals -2. E to the power of -2 equals this. And now I'm just going to minus 1 on both sides, so x equals 1 over e squared minus 1. So this is the nicest way to write it. And I don't need another point, that's 2 points, that's enough. So there's my, my graph of y equals log e x plus 1 plus 2. Right, let's see what's next. Okay, so this one is this is dilations here. And look, it's not asking us to label the dilations, but look, I will anyway. This dilation, the first one, and here is the second dilation. So the first dilation affects x, so dilation factor 1/4 from x-axis. And really, I mean, it affects y, but it's from the x-axis, I should say. That would affect y. And the second dilation is dilation factor half from y-axis. And again, it's nice because you can remember x comes before y. So the yellow one is before the blue one. X comes before y. So parent graph. And now dilations, well, it's going to change the shape, but on a sketch graph, you're not going to be able to really see that. So in this case, we only have an x-intercept that's going to show. So we do need to add a second point on there. And I'm just going to do it here. So y equals 1/4 log e 2x. Well, if I'm going to do the x-intercept, when y equals 0, so that's going to be 1/4 log e 2x equals 0. So this 1/4 is going to divide out. So in other words, when we find just the x-intercept, that 1/4 could be 1/8, it could be 7, it could be -5. You're not going to know that. I mean, if it was negative, you'd have a different shape. It would be a reflection. But any value here will give the same x-intercept. So we will need to find another point to show that we've taken into account the quarter. So 2x equals e to the 0, which is 1. X equals half. So our x-intercept is half. And now I'm going to choose a second point so that I can take into account the quarter. So let's put one here, and I'm going to do, not the y-intercept, sorry, when x equals e on 2. And you'll see why, because it's going to give a nice point. Y equals 1/4 log e 2 times e on 2. Well, that's going to give me y equals 1/4 log e. And log e is 1. So y equals 1/4 times 1, which equals 1/4. So it means that the point I get is quite nice. And I didn't have to choose that point. You could have chosen something else. But this is kind of nice. So this would be a good choice. All right, let's move on. 2 more. So now we've got negatives, we've got the reflections, and this has a double reflection in it. So look, this will be quite quick, this one. Parent graph, our first reflection, so this is y equals log ex. Let's do y equals negative log ex. So that's the reflection where you can still only have positive x values. So that means it's going to look like this. And now let's go y equals negative log e neg x. So we need to have negative x values, which means it's a double flip. So I'm going this way as well. So now once again, I'm going to do my x-intercept when y equals 0. So neg log e neg x equals 0, log e neg x equals 0, negative x equals e to the power of 0, which is 1. I'm just going to put 1 there because I'm running out of room. So x equals neg 1. And this is another one of those ones where without doing a second point, you have not even considered that this is a negative graph. So we have to have another point so that we're able to do that. I'm just going to say negative e. So when x equals neg e, that means I get y equals neg 1 times log e. Negative e is positive e. Y equals negative 1 log e is 1. So my point is neg e neg 1. And that's my second point. So if you're not sure about the second point, put it in. It doesn't hurt to put it in. But where it is absolutely necessary is when you do not see the effect that one of the transformations has on the graph without doing a second point. So the last graph I wanted to do was this one here. So I've just added this one in myself because people don't know what to do when you have like this. And it's the same as if you had a hyperbola. You would change that hyperbola to 1 over negative x minus 2. So you would remove whatever's in front of the x. So we do this here too. So we get y equals log e negative x minus 2. So first of all, we see it's a reflection about the y-axis, and then we're going 2 units in the negative direction, in the positive direction of the x-axis. So if you hadn't done that, you might have gone the wrong way. So parent graph looks like this. Y equals log ex, and then now I'll do the reflection. It affects the x values. It's here. It's a reflection about the y-axis, so we're flipping this way. Y equals log e neg x, and now I'm going 2 units in the positive direction. So actually I put that in the dilation column, but that's a reflection. And now I'll do my horizontal shift. So 2 units in the positive direction. So x equals 2, and it's going to be something like this. Looks like I've got x and y intercept here. So y intercept x equals 0, y equals log e 2 minus x. So log e 2. So I get, it's my y intercept, so 0 and log e2. And my x-intercept, so y equals 0, log e x, no, 2 minus x. E to the power of 0 equals this, 2 minus x equals 1, anything to the power of 0 is 1, neg x equals 1 minus 2, neg 1, x equals 1. So I have 2 points. It's taken into account all transformations. So that's our log graphs using the table of transformations. A little bit messy, I must say, but you know, we took into account all transformations and especially considered reflections there and when we have to have 2 points. So this is the last one here. And we've got to find the values of a and b here. So this is y equals log e x minus a plus b. So, well, the easy part is the asymptote. So we can say y equals log e x plus 3 because we're going in the in the negative direction, so it's the opposite. So then we just need the plus b. So really, I mean, you can just sub this in, and I mean, there's no other way to do it. So log e squared minus 3 plus 3 plus b equals 0. Well, this is going to be log e squared plus b equals 0. And then, well, now this is quite straightforward. We can minus b on both sides. So neg b equals log e squared. And I'm going to take that out the front. That's going to give me neg b equals 2 log e. Look out for log e or log e1, those ones that you can actually solve. A lot of people will leave them like that and then it's not right. Log e is 1, neg b equals 2, b equals neg 2. So it must be negative 2 there. So my final equation would be y equals log e x plus 3 minus 2. And it does tell us to find the values of a and b, so we must be careful that we actually do that. So our equation says negative a, or take away a. So if we've got take away a must be negative 3, because it's x minus minus 3 will give us the plus, so it's a little bit tricky there. And b is going to be neg 2. So if this had said a negative here, then b would be positive 2, because it's already taking into account the negative. But it's not, it's a plus, so we can leave it like that. So I believe that completes the examples for log graphs.